Our project is the watermelon versus rubber bands experiment, which focuses on energy and momentum. We will be demonstrating the relationship between the rubber bands and watermelon, how elastic potential energy is occurred in the experiment. We will also determine how many rubber bands it would take for the watermelon to pop. Our driving question for this experiment is, what is the effect of the elastic potential energy of rubber bands on watermelons? Also, we were wondering how many rubber bands would it take for the watermelon to explode? Our hypothesis was 600 rubber bands. The materials that were used in this experiment were a big watermelon, 600 to 1200 count rubber bands, some apron and goggles for protection, and a roll of mask tape to hold the watermelon in place. In this experiment, Hooke's law of elastic force would apply. It is the law that states that the force needed to extend or compress a string by some distance is proportional to that distance. Elastic potential energy is the stored energy of an object due to stretching or compressing. It is equal to the work done by the elastic material. Elastic potential energy can be determined by dividing the product of the spring constant and the square of the distance compressed or stretched by 2. Our group decided to split among 2 partners each and divide the amount of rubber bands we plan on putting on the watermelon. Here we are putting the first 300 rubber bands on the watermelon. And here are the rest of the 300 rubber bands that we attempted to put on the watermelon.
Okay.
Besides our complications, as we attempted to put the 492nd rubber band, our watermelon decided to...
How am I supposed to put the rubber band over?
How are we supposed to...
Oh! Oh my god!
Oh my god!
We seem to be recording.
Oh, go ahead!
You recorded that?
Yeah.
Okay. Woo!
Jeez, that scared me.
That's good!
For the English component, we wrote a narrative essay that described the anxiousness as well as excitement we felt while performing the experiment. We also analyzed the physics aspects of compression and elasticity. For the social studies component, we compared the rubber bands and the watermelon to a garbage truck and trash. As the rubber bands compress the watermelon, a garbage truck compresses the trash. The real-world benefit is that it prevents pollution because the size and quantity of the trash is reduced as the result of the garbage truck compressing it.